is a very exciting place. It's a learning ground where we can learn to live off the land and harvest its resources for local use. The moon is a stepping stone to great things beyond. There's a lot that we can learn from the moon about ourselves and the formation of the solar system, and ultimately where we came from. Astrobotic is a lunar logistics company. We take packages from around the world, we bolt them up on our lander and fly them to the moon. There's only been 3 nations that have ever landed on the moon: the US, the Soviets, and just recently China. And what we would like to do is make it possible for every nation to land on the moon. We certainly have a long list of people that say there's no way that that's possible. And what I can say to them is that it is possible, and it's happening now.
We use SOLIDWORKS to design every mechanical component that we have. It took several years to do the first designs for Apollo, 20 or 30 missions to the moon before we really touched down safely. We're trying to do that in essentially one shot. We're using simulation resources and the rapid prototyping resources that are available. In order to get to the moon, we launch into space, and that launch is a very, very harsh environment. It's 9 Gs, acoustic loads, huge shocks and vibes. Once we get into space, you have to deal with vacuum, you have to deal with the thermal environment. Your heat builds up in a component, and you need to spread that out. SOLIDWORKS is one of the main tools that we use that allows us to take a design, send it out to a 3D printer, figure out that there's a flaw in the design, and then rebuild it very quickly.
Griffin is our lander, designed to carry cargo to the surface of the moon. Polaris is our rover chassis. This is like our pickup truck for the moon.
Griffin's architecture is really centered around delivering payloads. Satellites, rovers, retroreflectors, different science experiments. That architecture, that low, flat architecture, is really built to accommodate many, many different kinds of payloads. We need the center of gravity of the lander to be within about 5 centimeters. We start with a CAD model, we mock up all of the different payloads onto the vehicle.
I find SOLIDWORKS to be a very robust program. It's very easy to use even with complex assemblies. So the payloads nominally would integrate right here to these holes. And SOLIDWORKS allows us to import the geometry and inspect how the payloads interact with one another and how it affects the mass properties of the vehicle.
Polaris is designed to operate at the poles of the moon. The poles are really interesting. It's believed that there's actually quite a bit of water in the soil. But there are unique challenges in operating at the poles. One of them is that the sun appears to orbit around the vehicle. So we've built the solar panels to be able to collect energy in all directions and allow the vehicle to operate in any orientation.
SOLIDWORKS is so common in industry that we can actually pull native geometry from a number of different vendors, incorporate it into the lander, and look at the shift in the center of gravity of the vehicle. It's very simple to do, and it really helps us optimize the layout and geometry of our assemblies.
When we land on the moon, it'll be the first time any non-government agency has landed on the moon, and that is going to be revolutionary.
This is just the very beginning. Decades from now, flights to the moon will be routine, and then we go beyond the moon. We can then go to Mars and deeper destinations. We'll learn to live off the land and harvest those resources. And tools like SOLIDWORKS make that possible, and will continue to make that possible.